Hello, everyone. Today we'll be working on the final problem of assignment number 10, which says problem number 3 here, but we know it's problem number 4. Now, if you looked at this problem, you would have noticed that a lot of these dimensions, a majority of them actually are missing. This was done intentionally, so we can learn a new skill, which is using an existing dimension to take an educated guess or a measurement in this case of what these other dimensions could be. Um, so I would recommend finding a software that, if you're doing this digitally, finding a software that has some sort of ruler on it or something that you can measure with. In my case, I will be using OneNote since I have a Surface Pro. So this is Microsoft's technology, and they have a built-in ruler here. Um, Alternatively, you could use a piece of paper if you have a physical ruler. In class, we did this on the whiteboard with one of our students' rulers. So there's many ways of doing this, but you do need a tool to measure with. So the way this works is we will be using ratios to find or estimate what our dimensions are. And I'll do an example here. So we're given that this dimension, this vertical dimension, is 0.45 units. So I want to find out what that is on my ruler. So 0.45 units on my ruler is 1 mark, 2, 3, 4, 5. I'm sorry, 1, 2, 3, 4, 5, 6. And then guessing after that, maybe about a quarter. So I'll do this in blue here. Um, 0.45 is about 6 1/4 on the ruler. And I could use this to find the overall length of this part, the overall height. So I will count how many marks it takes to get this overall height. And as a shortcut, this specific ruler has a longer mark every other fifth tick. So I know this mark is 5, this marks 10, this marks 15, 20, 21, and about a half, 21 and about 3/4. So if 0.45 is equal to 6.25 on my ruler, then down here I will write, I already forgot what value that was, 5, 10, 15, 20, 21, 21 and 3/4. And what I want to know is what this dimension is. I'll set that variable to be x. So this is the ratio that I have set up. So all I have to do now is solve for x. And I'm sorry, I'm not doing this on a blank piece of paper. I have there's a bunch of stuff going on, but we could erase this afterward. So let me make sure this is set back. Might have zoomed out a little bit. Um, 5, 10, 15, 20, 21, about 3/4. Okay. So this is my equation set up. Now I have to solve for x. So what I could do is I could cross multiply, and that would give me 6.25 times, let's not use that since we have a variable x, times x is equal to 0.45 times 21.75. So if we divide 6.25 to both sides, we get x equals 0.45 times 21.75 all over 6.25. We'll grab a calculator and do some math. my estimation here says that x is equal to 1.566, and I will round that up um, to the hundredth place. So x is equal to 1.57. And so I won't forget, I'll write that down. This dimension is 1.57. So we need to repeat that process for all these other dimensions. So I will be erasing my math as I go. Feel free to pause the video, just because there's not a lot of space on this sheet to use as sketch paper. So I'm going to be trying to keep it clean. Let's do the same for this dimension down here. So I will move over, say start on this mark here. So 1, 2, 3, 4, 5. I say it's about 5 1/3. So again, if 0 point, and we could use the first initial ratio that we measured, we can use that for each calculation. So if 0.45 is equal to, I believe it was 6.25, and the measurement we just took was 1, 2, 3, 4, 5, calling that 5 1/3, more or less. Then let's find x. So we can do the same math, cross multiply again. I'll just write down final equation to save us some time. X is going to be equal to 0.45 times 5.33 over 6.25. And if I type that into my calculator, 33 divided by 6.25, I get x is equal to 0.383. So rounding this number to be 0.38 for this dimension. Again, so let me I'll keep this. The only value, if you guys have noticed, that is changing is this value here. So that's all I will delete or erase along with the final number. So we can keep using this preset formula to find our answer. So we have these two dimensions. We also need to find this horizontal dimension. We're just going to fill in these empty boxes. So let me rotate my ruler, which unfortunately I have to do manually. So bear with me. All right, here it is. Now let's take a measurement of these lines, this dimension. So again, 1, 2, 3, 4, 5. Every fifth tick is a slightly longer line. So 6, 7, 8, 8 3/4 is my guess. So for this value, let's use 8 3/4 and move this out of the way. So then 8 3/4. Let's do some math again. Times 8.75 divided by 6.25. So the number that gives is 0.63. 0.63. Let's move on to the next one. Okay, so we have that dimension, those two. We have a dimension up here that we should also measure. 1, 2, 3, 4, 5, and let me line this up. 1, 2, 3, 4, 5, and about a quarter. So 5.25. Again, let's do some math. 0.45 times 5.25 divided by 6 and a quarter. 0.378, and we could round that to 0.38. This number, I'll leave it in three significant or four significant figures up to the 100,000th place. Just because I'm looking at the filled out sheet, and for some reason they had that number up to the thousandths place, so I will not round this one specifically. But if you did, no big deal. I just want to be a little bit more consistent with what the filled out paper is, which we'll take a look at. So we're done with all of this math. This value should be 0.378. Let's see what other dimensions we're missing. We have a few dimensions in here, which we could use the same ratio that we've been using. However, this let me scroll over. This detailed image is a lot bigger. It's magnified, so we might get more accurate results over here. The only downside is we're gonna have to set up a new equation, but no big deal. So let's erase all of this so we can move over. Let's scroll over here to this detailed view. The base measurement I'll be using is the 0.22. So let me rotate my ruler once more. My digital ruler. I don't think I've ever used a digital ruler until this assignment or before this assignment. All right. So let's line that up. And I know my ruler doesn't have any units. However, for ratios, ratios are unitless. So the units don't really matter in this instance. Okay, so if we're gonna set up another equation saying 0.22 on the paper on this drawing is equal to 1, 2, 3, 4, 5, 6, 7, about 7.5 marks on the ruler. And we could use this to find our missing dimension. So we could find this vertical dimension. Let's line it up here. 1, 2, 3, 4. It's almost to 5, but not quite. 2, 3, 4. Roughly 4.75. Yeah, 4.75. So again, let's solve for x. We know x is equal to 0.22 times 4.75 all over 7.5. 4.75 divided by 7.5. My calculator says that x is equal to 0.139. So we can round this to 0.14. Let's delete this or erase this and do the same for this horizontal line. So again, we'll rotate my ruler one more time, which I have to do manually, but it is what it is. All right, let's line this up. So this dimension is 1, 2, and we can use these dimension lines to get a more accurate result. So 1, 2, I say it's about 2 3/4 of the way, 2 3/4 marks. So this number is 2.75, as is this one. 0.22 times 2.75 all over 7.5 gives me 0.0806. So this can be rounded to 0.08. Erase this. We've found both of the missing dimensions here. So we're done with this detailed view. Let's erase our math. Okay, we have those two dimensions. Have these filled out. We're missing, see, we have one up here too. Let's fill out this top view. So I can no longer use the same ratio, so I have to set up a new ratio. Or since these two are scaled, I can use the same ratio we were using initially with 0.45 being equal to 6.25, which I will do for at least this diameter. So let me write that down. I remember it was 0.45 is equal to 6.25 on the ruler. So let's measure, let's go ahead and measure the diameter. Since I don't want to count every single line or maybe get lost, I'll just do half and then multiply by 2. So the radius is 5, 5, 6, 7, 8, 9. The radius is 9, so we know the diameter would be 18 lines. So this number should be 18 over x. So x is equal to 0.45 times 18 all over 6.25. Do some math. So x is equal to 1.296. We can round this to be 1.3. I believe there was one more on there. Yeah, this distance. Instead of measuring these angled ones, I will measure this horizontal gap because these are at an angle and I want to make sure I'm taking the most accurate. And since I don't know that angle off the top of my head, the easy way out is to measure this one over here on the side. And I could have also done this one, but it has a drawing in the way and making it a little bit more cluttered. So the cleanest one for me to do, in my opinion, is this guy. So this measures to be, oh, it's very tiny. I would say about a third. So let's actually use a third as a fraction. try to confuse you guys a little bit. 0.45 times 1/3 divided by 6.25. X is 0.024. So if I'm rounding this to my hundredths place, this would be 0.02. All right, we have those two. So let's erase our mess over here. And then finish up with this dimension. So let me rotate. And we can use the same ratio since all of these are drawn to the same scale. Just one more. All right. We will use the same math. 0.45 is equal to 6 1/4. This is X. What's our measurement? Our measurement is 5, 6. I would say 6 1/4. So X is equal to 0.45 times 6 1/4 divided by 6 1/4. So we know this cancels. Or, yeah, so this is 1. This cancels to be 1. So X is equal to 0.45. I believe that's the last dimension. Let me scan, double check. Erase this first, because I believe it is. Yes, I think so. Okay, let me turn off my ruler. No longer need that. And now that we have all of our dimensions, I feel like we should compare this to the answer sheet. So let me move this out of the way. Go ahead and minimize this. We have the filled out answer sheet here. See if I can put these side by side. Or you could also just pause the video and check on your own, but I want to check myself. Let me move this. All right, so 0.45 is same as our 0.45, 0.02, 0.13, 375. We're off a tiny bit there, 0.378. So by the 10th, 100, by a few thousandths, no big deal. 1.57. Also here, we're off by a hundredth. Also no big deal. We got really close estimations. I mean, most of them are on the money. I think that was due to having a digital ruler because we did also do this in class with the physical ruler and on the whiteboard, and we also got very similar answers, but not as on the money as we did with these here. We just had one or two that were slightly off, which is okay. If you're ever in that situation and you have to use those ratios to guesstimate other answers or other dimensions, I would say this is more than acceptable based on the fact that we're estimating these values instead of being given them directly. So that's the math portion to this problem. now that we have these values, we can go ahead and use our software, um, SolidWorks software to make the part. Um, so I'll be using this drawing that has the given dimensions, but I just wanted to show you guys how to do, um, how to use that sort of math for that given scenario. So let's open up SolidWorks. Let's get ready to make our part. So I'll start a new part file. Our units are in inches. So we'll set that over to inches. Now, by looking at this part, I can see we're given a few cross sections, and combining that with the fact that our part is round in nature, I believe we can use the revolve feature to create this part. So I will use either one of these cross sections to make that initial sketch, and then we can revolve that around the center. So let's sketch on the front plane. I will be looking at this view here, and this is the sketch that I will be making for our revolve. So I'll start by making a line. I'll say my origin is at this point, right down the middle at the bottom. So I need to get to this point. So to find this distance would be the diameter divided by half, 0.63 over half over 2. That gives me this point to this point. So that's where this endpoint is at. Do I know? I would also need to know this overall length, which I'm not sure I'm given. Let me check my other views. It's not given here either. We are given our diameter for this top view. So it doesn't look like we're given this distance. And normally when I run into this kind of problem, when I run into an obstacle or something I can't figure out, I'll stop trying to pursue that and then pick another direction to continue drawing in. And then hopefully we can circle around back to this. Or at some point when we come maybe full circle, we won't even need to know this information because we could just finish our sketch. So instead of going out this way, I'm still at this point. I'll start in the clockwise direction, making this cross section here. So let's make a line. Nope, it's not what I want to do. I want to make a line. I know it's going to be a vertical line, and the distance for that line is going to be 0.39. Now I need to move this distance back inward. So I'll make a line, and let's do some math for that distance. So to find this piece of this line, I'll take half of this diameter and subtract half of this bore, or half of this diameter, leaving me this line. So I'll type it in here for a visual, 0.63 over 2 minus 0.375 over 2. And that's the distance there, 0.1275. So then we'll move back up. And I could find this distance by subtracting 0.57 and 0.39. So this is 0.57 is our overall height minus this height gives us this height, or 1.8. That's not correct. That doesn't even look right. I bet if I move over here, there's that one that I was missing. So it's 1.57 minus 0.39. That seems more realistic. It's also good um, to double check. Sometimes you want to work with logic. If some things don't look right, maybe go over it again. It's a good practice. So now we can find this horizontal line because we know the diameter for the top is 1.3. So from the center here to this outer line is 1.3 or 1.3 over 2. So to get this distance, it will be 1.3 over 2 minus the radius of this bore. So 0.375 over 2, 0.4625. Okay, now let's move on over to our detailed view here to get the rest of these dimensions. So we know we're at this point. Let's draw a line. I'm not sure on the length yet, so I'll just make it, I'll eyeball how far I want to make it. But the important thing that we do know is the angle. It's 30 degrees. Um, if I were to make a line vertically, that would be 270 degrees. So if I want to make, let's see, 270, I would add 30. So 270 plus 30 is 300. And just to double check for the class, this angle should now be 30 degrees, which it is. I'll just leave that dimension there. Not sure if it'll like me deleting this line. No, I deleted the dimension with it. That's okay. So now I have this line, but I don't know the distance quite yet. So I wonder how we can approach this. The way this is going to work is to find this endpoint of this angled line. I'm going to make a vertical line that is 0.22 minus 0.01, so 0.21 units long, and wherever that it lines up with our angled line, that's where we need to cut it off. So this is that right? Yeah, that looks right. So 0.21. I'll draw another horizontal line to make these intersect. So if I trim these two and also these, this is my line. It's at 300 degrees or 30 if you're looking at this angle. Now I can make my little vertical line that is 0.01. Let me double check to make sure I'm recording. Yes, I am. Okay, so 0.01. And then I need to make this horizontal line that is 0.08. Another vertical line. What is this? 0.14. And then use this as a reference. Do I have an angle for this? I do. So this is what I meant when we can use this line, or we can use, if we can't find this dimension or we're not given this dimension, we could have used the measuring method with the ratios to find a numerical value for this. But also we can come back to that once we go full circle. So this is what I meant. Now we can create this line, which again, I don't know the length of it, but I do know its angle. So if a vertical line measures 270 degrees minus that 8, so this should be 270 minus 8 degrees, 262 degrees. I don't know this length, and I also don't know the length of this line, but I do know that these two lines intersect. So if I make them intersect, all I have to do now is trim. Therefore, I don't need to explicitly know these measurements for the lengths of these lines. I can still get these values. Let me also draw my line that I will use to revolve. By looking at our sketch here, I don't like how this line doesn't seem like it's proportionally correct to me, and this one doesn't either. And now that I'm looking at it, I took this dimension to find the distance for this line, but that was incorrect. This outer radius, outer circle would be our distance from here to here, from the outermost edge, or this line. Although it wasn't given, that there was no space set out here for this dimension of this circle. That's the one we should have used, but we didn't find that value. So let me open up OneNote once more, and let's quickly find that number so we can fix our drawing. So let's pull up the ruler again. Leave the, if I remember right, it was 18 marks, 5, 10, 15, 16, 17, 18 marks for the outer circle. Now for the inner circle, let's line this up. We got 5, 10, 15 here. So this is 14 and a half about. So x is equal to 0.45 divided by 6.25. And we said this was 14 and a half. 5, 10, 15, 14. Yeah, about 14 and a half. A little bit of math. 1 point, so let's label this somewhere. So this diameter, we could do better than that. Nope. Come on. Why is it doing it? This diameter is 1.04. 1.04. Let me write this over here so I can see it. Which means should maybe redo some of this. Let's see. Hopefully, let me lock this. Let me, no, not fix these. I want to keep my relations. I just don't want these. to move. Let me fix this point. Is it gonna let me change this value? Yes. Okay. So I fixed this point. Let's redo this math, this time with 1.04 as our number. So this distance should be 1.04 over 2 minus 0.375 over 2. That looks a lot better. Let's see. What's this distance now? 0.3325. So we'll do the same thing to finish this. Again, 270 minus the 8 degrees puts us at 262. Go ahead and draw this line to intersect. We could trim these two. All right. So this is what we could revolve. Let's find our revolve feature. It already selected our axis of revolution for us. Of course, you want to revolve this 360 degrees. And also selected the contour or the area we want to revolve. So now we have the general shape of our drawing. Let's check our isometric. It's pretty good. Now all we have to do is create these slots in the piece. And this might look intimidating, but I don't believe it is. We're going to break this down and make it very simple. So if you noticed earlier, we were given two separate section views, and most people at first glance would think they're identical, and they look very similar. But if you notice on this drawing, the section views are different. So we have section CC. This is the top of the part. So this would be the top. So looking at section CC, we can see that these openings, these cuts, go all the way to the top of the piece. So that would make them these 6 openings here, these 6 slots. But you notice they don't go all the way down. So that's why in this cross section you have your shaded area at the bottom, because those pieces are still connected at the bottom of the part, whereas the top they're not. So you have this open area. Now let's also compare section view DD. Those would be these openings that are open at the bottom but don't quite make it to the top. So if you look at the section view for that one, you have openings all the way to the bottom. This is why this is unshaded. But at the top, they are still connected. So we will make these, we'll make the top ones first, the 6 of them, and then once we have those, then we'll come back and make the cuts at the bottom. All right, so let's create those sketches. First, let's find a plane that would suit what we want to do. Here, either the right or front plane will be fine. I'll just choose the front plane for no specific reason. And let's zoom in here on our view that we'll be using. So the sketch we want to make here will be to cut out this open region. And to do this, it would help me if I had sketch 1 shown. And also I could even use my section view tool to open up my section view here at my front plane. Therefore, I can see what I'm sketching since I'm currently working on this plane instead of having the outer regions of the body interfere with my view. So I want to sketch this open area here. To do so, I can retrace these points. Let me zoom in a little bit here. And this line will be 1 point, or I'm sorry, 0.45, 0.45, because I want to create this angled line. So now I can make this line, which I know is at a 45-degree angle. And that would allow me to trim this piece. And let's finish this line. And also I could trim here, here, and here. So this is the cut that I'm going to make. It is going to give me an error. I don't think if it does do it, I don't believe it will do it. If it does, it will be very messed up. Or it just won't like, it wouldn't want to make this cut. And I already knew that, but I wanted to show the error and also show a solution to the problem. So let's go ahead and make this cut if it lets us. I don't think it will. Again, we're on this center plane, so we can use, or we know we have to make our cut half in one direction, half in the other. So you can use both directions to do that. Type in half your distance here and half your distance here. But instead, there's a special function called midplane, which will automatically uh, separate your extrusion in two directions. So all you have to do is type in the overall distance. So we know these gaps should be 0.02, 0.02. Again, if we do the midplane, this will divide it evenly for us. All right, so we have that. Let's go ahead and create this cut, and it doesn't allow us because it will result in zero thickness geometry. So it gives us an error. Again, I already knew that would happen, but I wanted to show the error. So this cut, it doesn't allow it. A solution to this problem is we can't have these lines creating that zero thickness geometry, but we know we need this section cut out. So what I'm going to do is I'm going to offset. I'm going to use my offset tool. Where is it? Features, sketch. I like to double check if I'm recording sometimes because I forget if I hit record. I'm going to offset these. Did it freeze? No. Wait. Okay. Sure. It doesn't matter the distance. The important part is that I create lines that extend to the outside boundaries past this body here. The only line I don't want to change is this angled line. I want to make sure that cut is right where it's at. So I don't need this offset version of it. This is my only original line that I'm keeping. So what I could do here is extend this line out to intersect with these lines that I just offset. And then I could trim those pieces and then also go back and delete all of the interior lines that I will no longer be needing. So now I have an open region. Let me make sure this is fine. Now I have an open region that will make a cut past all of this. So let's try that again. Again, we're doing mid plane. Our total distance is 0.02. This region we want to select is this. It says midplane, but I don't see a second arrow. But by zooming in, I can see that it is cutting in both directions. Whoa, what happened? Got lost on accident. So I can't see it is cutting it in both directions. Oh, maybe the reason I can't see it is because I have my section view. Or I'm not sure. So it did make the cut. It's a successful cut. That's great. Let's exit the sketch. Let's also turn off my section view. So we have one successful cut. And this cut actually is representative of these that are cut all the way to the bottom. So I messed up by saying we were going to do the top 6 first, but that's okay. So now we have one. We need to have 5 more of these. So I would use, where is it? My circular pattern. The direction I want to go is in this circular direction. Equal spacing, of course, a total of 6 cuts. And the features and faces that I want to replicate is this cut here. So we'll turn on my preview, and get a look at my preview. So it looks like to be what I want. Go ahead and finish. And now I have 6 of those cuts. So do I still need this? I might need that. I'll leave that there. So we have 6 of our cuts. Now we have to do the other 6 cuts. So let's find a plane suitable for our sketch. Our first cuts were on the front plane. I can see that based on these views that I need to pick a different plane. I need a plane that splits these 2 cuts down the middle, which it looks like my right plane does. So that's very nice. I already have it ready for me. So let's make a sketch on our right plane this time. And again, we can use a section view of the right plane to take a look at what we're sketching. So we're in our sketch. We need to sketch this one this time. I wonder if I can flip this. Is there a setting for that? Rotate. Maybe a few more times. All right. I just wanted to rotate it so it would match up with the sketch that we're working on. So again, I need to cut out this open section here, and I need to keep this shaded area. So I will do the same method of tracing. Can I not? Might have to be very careful here on where I click onto. Doesn't seem like it wants to lock onto any edges. Oh, there's that one. But actually, I think this is a good way to showcase something or prove a point. So this line is 0.45. Not letting me lock onto that point there. Maybe I can dimension it. Oh, it looks, maybe this is, okay. So let me make it. It's good. Let's use some dimensions just to make sure everything is where it should be. From that point to, I don't know, say the origin, we should have a vertical distance of 0. I want this line down there. And now that that's 0, I can fix this. Yes, I understand these interfere with each other, so I can delete the distance. I'll just keep this fixed point. And let me change this dimension to 0.45. All right. Now I can draw this angled line from this point. See, this angle needs to be 45 degrees. So I believe if my vertical line is at 270 still, yes, 270 plus the 45. Not quite sure what that is, but we'll do 270 plus 45, 315. Now I need to, I don't need this anymore. Let me fix this endpoint and I'll extend this line a bit just to go in this direction. So right now it's 0.54. Maybe if I make it, I don't know, 0.75. Oh, it's not letting me extend it. Let's try that again. All right. So now I have the same line. It's important that we don't move this from where it's at. So it's creating the desired cut that we want. And the point I wanted to prove is, and the reason I'm doing this is because for some reason it's not letting me, or it's not generating the points that it normally does, like this. That would make me know that I'm locked on to that specific point. So I don't want to mess up. But my point is, this is the only cut that I need. Since the rest of my shape has to go around all this whole body, it doesn't matter what shape it is. I can draw zigzag lines and I can cut out this shape here and it would work. I mean, maybe if this doesn't get in the way of anything. But that's maybe an exaggeration of my point. I don't want to mess this up either. So let's play it safe and just create a simple box. Again, these lines are not being measured. We're just creating a closed off area that's going to cut this region of the shape out. So let's do an extrude cut of this region here, mid plane, still 0.02. All right. If I turn off my section view, I can see I've successfully created that line. Now let's do the same thing we did with the other circular pattern. So let's create another circular pattern. The direction is no, that's not what I wanted to select. The direction is this circular face, 6 spaced equally. This is what we want to pattern. This cut here. Look at our preview. Preview looks good. Finish that. Now we have those 6 cuts. So I could turn off or hide. No, I want to hide this as well. One last final check. So I'll look at my section view, see my right plane. Let me make myself normal too. So as you can see, this is section view CC of my right plane. And I have all the correct features. This is open area. This is closed off. I have all my cuts and openings. Everything looks 100% correct. Let me switch this to my section view of my front face or my front plane since I know I have to rotate this. And that would give me section view DD. So let me make myself normal to this. Now we can compare our section view. Again, this is open area. This is closed off. All our cuts, openings, everything looks 100% right. So I can turn this off. Move over to my isometric. Let's check out our drawing. Everything looks good. So that was problem number 4. That means we're done with assignment 10. Thank you.